Hey guys, it's Thomas here with Technovision, and welcome to the next part of our Minecraft modding tutorial series for 1.16. In this episode, we're going to be creating some custom ore generation so you can get whatever block you want to generate randomly inside of the world in any of the 3 dimensions. And you can use any block you want, but I did create a custom ruby ore block off screen before the video, and I wanted to do this just so I could show you. If we come over to our blocks package here, I did make a custom class for this just like with our ruby block. And if we open both of these, you can see that this ruby ore, well, this is our ruby block that we made on screen together, but our ruby ore is pretty much exactly the same, except whereas ruby block extends block, ruby ore extends ore block. Now, the reason I did that is because when you extend ore block, you get access to this special method here that you can override called get XP drop. And you can access this as long as you extend ore block, and this will allow you to set an XP amount that will drop when you mine your block. So just like every ore in the game, for the most part, when you mine it, you can get experience points. I think iron doesn't do that though, except because you get XP for that for smelting. But things like coal, all those things drop XP, and that is how you do it, by using this method. And of course, as long as you know Java, you should be able to set up some cool stuff with this, like creating random amounts of XP, calculating the fortune level or the silk touch level and having that affect XP, whatever you want really. But I just wanted to mention that, so make sure your block extends ore block if you want this special method. Otherwise, it doesn't matter, we can use any block we want to generate. Alright, so in order for us to get started, we want to make a new package under our main package here, our tutorial or whatever the name of your mod is package. Right click, new, package, and we're just going to name this world. And this is going to have some more stuff in it later once we get to like custom biomes and stuff like that. But for now, just make a new package in here called gen, which is short for generation. And inside of this package, we want to create a new class. And we want to name this, it really doesn't matter, but I'm going to put mod or gen. You could also put like or a gen handler, that works too. Whatever helps you understand what the class is. So inside of this class, we're going to have all of our ore generation related stuff. Now, what we want to do is make sure that we have the @mod tag above. So above your class here, your class declaration, you want to do @mod dot event bus subscriber. That is definitely not how you spell subscriber. Subscriber. And in parentheses here, we want our mod ID to be equal to tutorial.modid. Let me import mod @mod tag just so this is a little bit easier here, and import your main class as well. So your mod ID should be equal to your mod ID, of course. So from your main class, you want to get your mod ID like we do all the time. And then we also need to make sure that the bus is equal to mod.event_bus.bus.mod. There we go, all good. Okay, so now we can actually use this class for subscribe events, which is what we're gonna do to generate this ore. Now, if we come down here, a few spaces down, we wanna make a public static void method. So public static void, and we're gonna name this just generate ores, I guess, because it is going to generate all of the ores. So generate ores, and this is gonna take in a forge mod loader load complete event. So FML load complete event, and we're just going to name this event, and add some curly braces. Now we need to add a @subscribe event tag to this. So @subscribe event above the method here, and this is going to be an event. We haven't really talked about events yet. I'll go in more detail in a full video about events later on. But essentially, whenever Forge mod loader gets loaded, it completes its loading phase. Basically, when you first run the game with this green triangle. Once that load complete event gets hit by or started, I guess is the right word, by the Forge mod loader, it's going to run whatever is inside of this this method. So that's what we're going to do. We're going to generate all the ores on load event. So in order to do this, we want to loop through every single biome in the game. Now the best way to do this is just a for loop. So for biome, and we're just going to do a, well, let's import biome first. So we're gonna loop using every biome within forge registries.biomes. All right, so what this is doing is it's just getting every single biome in the game, and then we're looping through each one and assigning it to this variable here each time. So now that we have this variable, we wanna do 3 checks. One for if the biome is in the nether, another for if it's in the end dimension, and then a final one if it's in the just the regular overworld. If you're not doing oregen in the nether or in the end, you can just skip those if statements. No reason to have them if you're not going to use them, but I'm just going to show all of them, of course, just in case you are. So first one, we're going to do if biome.getCategory is equal to biome.category.nether. So let me explain this for a second here, and we'll add a little tag up here, a little comment that says nether generation. So once we have this biome each biome that we're going to loop through, if the biome category, which is essentially like what the biome is, or what the where the biome is located, if that's equal to the nether, meaning if it's like a biome inside of the nether, then we're going to run this code. And what we're going to run is a custom method we're going to make. So let's set these up first, and then we'll do those custom methods. So we also want an else if biome.getCategory is equal to biome.category.theEnd. And again, everything inside of here is only going to run if the biome happens to be from the end dimension. And then finally, else, if it's neither of those, if it's not in the nether and not in the end, then this will run, which is just the overworld. And let's add some more tags here. I keep saying tags. I mean to say, what's the word? Comments, Java comments, end generation, and just so it's clear, one more time, world generation. And let's move this over here. All right, so again, if you're not generating in the nether and you're not generating ores in the end, you can just delete these and just have world generation here. No need to have them if that's the case. So we need to make our special little method that we can call. So below this method that we've just created, we're gonna make a new private method called private static void genOre. And this is going to take in a ton of different parameters, so bear with me. We're going to run through all of them, I promise, and it will make sense by the end. So first thing is a biome, so biome. Then we need to take in the count, int count. And I'll explain what all these are in a second because I promise they're actually very important. Int bottom offset. Then we also need the int top offset, the int max. And then this next one is a long one. It's the or feature config dot filler block type, and then we're naming this filler. And then I gotta scroll over because it is so far off screen, but I think this is the last one. No, it's the second to last one. Block states, it's a capital S. Block states, default block state. You know what? Let me just move this down here just so it's easier for you to see. Just for now. Block state default block state, and let me import block state as well. And then the final one is the integer size, so int size. All right, so we've got all of the parameters. I know it's a ton of them, but you'll see why in a second. It's actually very important. Bring this up, but just know that that's what this is. One last look at it, and we need some curly braces as well. So inside of this method, we're going to actually register your ore as something that needs to be generated. So we can do that by first getting a range. So we want to count range config, and we're going to name this range. And this is going to equal a new count range config. And this is going to take in the count value, the bottom offset, the top offset, and the max value. Okay. Semicolon, sorry, this is just so much information to get through, so bear with me. Next thing we need to do is the feature. So, and again, I will be running through this, I promise. I'll explain all of it. We need an or feature config named feature. This is gonna be equal to a new or feature config, and this is gonna take in the filler and the default block state as well as the size. We can add a semicolon. All right, now that we have those two, we need to actually add the feature. So we can do that by doing, or actually I think we should get the config. Let's make a config variable just so it's cleaner. So let's do configured placement. I'm gonna name this configure, or config. Is going to equal placement dot count underscore range rather, dot configure, and we're just gonna pass in the range and add a semicolon. All right, so now that we have our three variables here, we want to add the feature. We could do that by using biome dot add feature, and we want to pass in a few things. First, the generation stage dot decoration, and we want this to be underground ores. You can see there's a bunch of different ones. We'll be touching on these later when we make like custom structures that generate, but for now we want underground ores because that is what we're making here, we're generating. And then we also need a feature, so feature dot ore. Again, there's a couple in there, but we want to really only focus on ore right now. Dot with configuration. We want to pass in our feature we just made, our feature from up here. And then move over, I believe it's one after this feature, this with configuration method, and then just do dot with placement. And we want to pass in our config, which we made right here. All right, so that is it. I know it's a super long method, but essentially what this is doing is creating the ore. It's not creating the ore, it's registering it to be added as a feature to the biome, which essentially means that it'll be generated as an underground ore. Okay, so now that we have our method, we can actually use this method to generate our ore. So first ore I'm going to do is just the overworld, and we can do that inside of our else statement here. Again, if you don't have these if or else if statements, you can just kind of throw it in here in this for loop. But inside of our statement here for world generation, we're going to just type genOre, and you want to pass in first the biome, so just biome. Next you want to pass in the counts. Now this is going to determine how rare your ore is. The higher this number is, the more common you'll find it. So for example, if we were to put 20 in here, you would find this ore all over the place. It'd be super common. But if you were to put 1 in here, for example, it'd be super rare. You'd rarely ever find this ore. So the higher the value, the more common. I'm going to put this to 15 so that we can actually find our ore when we're looking for it, but you can set it to whatever you like. Next is the bottom offset. Now the bottom offset is the lowest possible Y value that your ore can spawn in. So if we were to set this to like 8, for example, what this would mean is that your ore cannot generate past Y level 8 downwards. So like 8 is the lowest possible Y value it'll ever generate at. I'll actually leave it there, but again, whatever you'd like to put there. Next is the top offset, and this is the opposite with the bottom offset. So this is like the top possible Y value that your ore can ever generate in. I'm gonna put this as 5, and that might sound confusing at first, but this is actually subtracting from another value that we're going to set in a second. So I would just set this to 5 if I were you, or anywhere between 5 and 1, and I'll explain why in a second because it will make sense. So next is the max value, and this is actually the top Y value that your ore can generate from. So if we were to set this to like 50, for example, just for this demonstration, what this would do is take 50 here, the max value, subtract the top offset value for a value of, let me write it out here, a value of 45. So this is the top possible Y value that our ore can spawn at. Now our bottom offset is 8, and that is our bottom. So what this means, what we've set here essentially is for this ore in the overworld, your ore will always spawn between 45 Y level and 8 Y level, never above this value and never below this value. And again, we got 45 here because we take the max and we subtract our top offset, and then the bottom offset is literally just 8. That's just what it is. There's no subtraction for this one here. So hopefully that makes sense. Again, set this for whatever you want the max to be, and then this to be whatever you want to subtract from this number, and then set this to the bottom offset, the bottom max. All right, after the max, we now have our next value, which is the ore feature config. So we want this to be, well, it depends. We're doing world generation overworld, so we want to do ore feature config dot filler block type dot natural stone. You'll see there's a couple here. If it's the overworld, you're gonna wanna use only natural stone, essentially. So always sort of choose natural stone for this one. Comma, next is the actual block that we will be spawning, the block that will be generated. I'm gonna bring this down here just so we can see it and it doesn't go off screen. But you can access your block by doing registry handler, dot, and then of course you can get your block from this list. Mine is the ruby underscore ore block, but again, you can choose whatever block you want. And then make sure to do .get as well. And then we also need to do dot get default state because we need the block state. Add a comma. And then this last value is the size. This is the maximum ore vein size that your ore will generate in. So you know how some like iron veins in the world have like 5 to 10 pieces of iron? That's what this value is setting. So if we were to set this to 12, for example, our rubies could spawn, our ruby ore could spawn in chunks of either 1 ruby ore all the way up to like 12 ruby ore blocks all clumped together. So the bigger this number is, the bigger the vein of ore is. I'm gonna set this to 6 just so it's more like vanilla sort of sized and it's not too big. All right, so this is actually done. We've actually finished our ore gen, and this will generate in the overworld now. So we can bring this up here, and this is all done. But I do want to show you how to do end generation as well as nether generation. So if you want to generate in the end, which is our next one, well, actually let's do nether first because end is going to require a few more steps. So if you'd like to generate in the nether, again, you have to make sure you have this check here for if the biome is a category of nether. And inside of here, we're going to do the same thing we said here. We can actually copy all of this just so we can make it easy for ourselves. And I'm going to change a few values. Let's make the count a little bit rarer, so maybe like 12. We can make the bottom offset like 5. The top offset we can make 5. We can just keep it as 5. And then let's make the max like Y80 because the nether, I wanted to generate all over the nether, let's say. Now, one thing that is very important to change with this nether generation is that instead of natural stone, we do need to select dot netherrack. If you don't do this, if you keep it as natural stone, it will not work. It literally will not generate in the nether no matter what. So you have to select dot netherrack here. And then again, select the ore that you want to get. Make sure to get the default state and then the size. Let's make this a little bit smaller, like 3 is the maximum that it can generate it in. Or maybe 4 is a good value. Okay, so now our ore will spawn in the nether and it'll spawn in the world. And again, just to remind you, every time you want to spawn a new ore in the world, just add another method here, another genOre method, and then literally just change the values and then change the block. That's all you have to do, and it'll generate. So this is all set up for you, really. Okay, so now we want to generate in the end dimension. So if you want to do this, you have to add a public static ore feature config. So come up here, and again, this is just for the end dimension. You want to make a public static ore feature config dot filler block type. We're going to name this end underscore stone, and this is going to equal an ore feature config dot filler block type dot create. And we need to create this. Let's pass in a enum name. Just end underscore stone is fine. Let's bring this down here so you can see it. We need to pass in a name in. We can just do end underscore stone. And then finally, the new block matcher. And we're gonna have this be blocks.endstone, end underscore stone. There we go. So what this is doing is creating a new filler block type. Now this filler block type, like I mentioned, what this is doing is determining what blocks should be around your generated ore. So in the overworld, it's saying make sure that there's natural stone blocks around your ore. In the nether, it's saying make sure that there's netherrack surrounding your ore. For the end, there is no automatic filler block type that is set for us, so we have to make our own. And for this one, we're setting that the block should be endstone. So we're saying, please fill in our ore with endstone. And again, you can make as many of these as you want, really. Anything you want that generates in the world naturally, and your ore will spawn next to that. And that's how you sort of make your ore spawn in specific areas and caves, or next to like specific stone types. So like if you wanted to make one of these for diorite, you could make it so that your ore only spawns inside of diorite or surrounded by diorite blocks. So that's what that is. And we can use this by, again, copying this genOre here that we made. Let's just copy it, paste it in, and we can change a few values. So again, I want this to be like a count of, let's make it like 18 this time, super common in the end dimension. And then for the bottom offset, we can just keep it, let's make it like 3 just so it's different. Top offset can be 5 again, and then max, let's make it like 80, just like the nether. And again, very important, we have to change the filler block type to our custom one. So end underscore stone. And we actually need to just use the variable, so you can get rid of all that unnecessary stuff and just use the variable here. And we are using the ruby ore, so we can keep that. And let's make the size like, I don't know, let's make it like 12 this time, much bigger. Okay, so we are now completely done. Your ores will generate now in both the world, the end, and the nether, and you now know how to add as many as you want. Now, one thing I want to mention is if you would like your ores to spawn in a specific biome, what you can do is, let's say we want our ruby ore to spawn only inside of the like a plains biome, for example. What you can do is come to your if statement, whichever category you're looking for, end, nether, or world, and you want to encapsulate your method here in an if statement that just checks like if biome is equal to biomes dot, and then you can just choose a biome. So like if we wanted, let's choose, maybe desert is a good one. So if the biome is equal to desert, then we can just encapsulate this in an if statement. There we go. So now this code will only generate our ruby ore if the biome is a desert biome. And you can do this for any biomes you want, as many times as you want. And that's how you specify it. That's how emerald ore only spawns in an extreme hills biome, in case you were curious. So now we can run the game and test it out. Okay, so inside of the game, make sure that you create a brand new world, because we do need to generate completely new chunks in order to get these ores to spawn. And in order to find them the most efficient way possible, we can just go into /game mode spectator, and that will let us see underground. And we should be able to find inside of our cave system here, hopefully not too hard to find. There we go. So we did find some of our ruby block there. That's my ruby ore block that I made. Let's see if we can find like a bigger chunk somewhere. Maybe in this ravine somewhere. Not there. There we go. So let's go to game mode creative. Let me get a torch here. And there we go. So we have our ruby ore, and it looks like this is a vein of like 2, or it actually is 4. So anyway, that does mean that it is generating in the overworld. And now I'm gonna go over to the nether, and I'm gonna go see if our ore is generating there. Alright, so I just went into the nether, and you can see actually right here, we did make it very common, but our ruby blocks are generating in the nether. And of course this texture doesn't really match the nether. Hopefully if you had a nether generating ore, you would actually make it look like it belongs in the nether, but this was just for testing purposes. But it is good to see that it is generating inside of the dimension. So now let's head over to the end dimension so we can check out our ore over there. Okay, so we're now in the end dimension, and if we come over here, oh, there we go. We can see our custom ore again, spawning in naturally in the end. And again, just like with the nether, hopefully if you have an end spawning ore, it will look a little bit nicer than this and actually match with the end stone. But once again, it is good to see that we have a custom ore that is generating. Alright, so that's going to do it for this episode. Thanks guys so much for watching. I hope now you can generate your own custom ores or any block that you want in the world. And yeah, I will see you guys in the next episode.